Good everyone, my name is Graphics. If you look at the front of your screen, there's a question that is displayed that is based on logarithm. And the question goes like this. It says, given log y minus 1 to base 4 plus log x over 2 to base 4 equals to a, comma, log y plus 1 to base 2 minus log s to base 2 is equals to a minus 1. Show that y square is equals to 1 plus a to the power of a. Now you need to solve this individually. So I'll pick the first expression first, which is log y minus 1 to base 4 plus log s over 2 to base 4 equals to a. Now recall, log b to base a plus log c to base a will give us log b c to base a. That means when you have two logarithms that are adding each other, you need to multiply both of them, right? So if I implement this law into the expression above, I'll be having log y minus 1 in bracket multiplied by x over 2 to base 4 is equals to a. Now I have successfully multiplied both of them, right? Now there's another law that says that recall log a to base b is equals to c. This will give us a equals to b to the power of c. What it means that if you have the log of a value to a particular base equals to a particular number or figure, the base of the log will go to the other side of the equal sign and lift it up, just like what you're seeing here. So if I implement this into the above expression, I'm going to be having x into bracket y minus 1 divided by 2 is equal to 4 to the power of a. Now the 4 has gone to the other side of the equation sign and lift the a up. Now, if you take 4 to a number in base 2, you'll be having 2 raised to the power 2. So if I rewrite this equation out, I'll be having x into bracket y minus 1 all over 2 is equals to 2 to the power of what? 2a, right? Now, you are going to make x the subject of the formula now. So making x the formula, that means 2 will go to the other side, I'll cross multiply. I'll be having 2 multiplied by 2 to the power of what? 2a, right? Now, recall, when you have two different values that have the same base multiplying each other, you're going to add the powers as a law of indices. So if I implement it, I'll now have x into bracket y minus 1 equals to what? 2 raised to the power 1 plus 2a. Because there's nothing on top of the 2 doesn't mean there's nothing there. There's a silent 1 on it because 2 raised to the power 1 is 2. So that I'm having 1 plus 2a here. Now, if I divide both sides by y minus 1, I'll be having x into bracket. I'll be having x equals to what? Because the y minus 1 will equate to y minus 1. I'll be left with what? S equals to 2 raised to the power 1 plus 2a over 1 minus 1. So that is what we are having here. So I'll just standard my x. Let's call it equation 1. Similarly, we apply that for the other expression there. So the other expression is telling us log y plus 1 to base 2 minus log x to base 2 is equals to a minus 1. Recall, log b to base a minus log c to base a is equals to log b divided by c to base a. So meaning that when you have two logarithms that are subtracting each other, you're going to divide them, just like what I did here. So we'll now have, if I now implement it in the expression above, this will give me log y plus 1 divided by x to base 2 is equals to a minus 1. Now, from this expression, recall, if I have log a to base b is equals to c, now if I want the a to stay alone, the a will now be equals to what? B to the power of c. That means the base of the log will go to the other side and lift the c up, just like I said earlier. So if I now implement it in the above expression, I'll be having y plus 1 divided by x is equals to 2 raised power what? A minus 1. The 2 is going to the other side and lift up the a minus 1. Now, another way of writing y plus 1 over x is 1 over x times y plus 1 over 1, because 1 times y plus 1 will give you y plus 1, x times 1 will give you x. So it's the same thing. So this will be equals to what? 2 to the power of a minus 1. But x is equals to what? 2 raised to the power 1 plus 2a over what? Y minus 1. What we proved earlier in our equation 1. Now we are going to substitute it into the above expression. So in doing that, anywhere I see x, I'm going to place 2 raised to the power 1 plus 2a over y minus 1. So if I implement it in the above expression, I'll be having 1 all over x. Instead of writing the x, I'm going to put 2 raised to the power 1 plus 2a all over y minus 1 times y plus 1 over 1 equals to 2 raised to the power a minus 1. Now recall, if I have a over b over c, it means I'm saying AC over b. The lowest one will come top to multiply the highest one there, and this is what we have here. Now, if I implement it in that expression above, instead of me having 1 over 2 raised to the power 1 plus 2a all over y minus 1, y minus 1 will go and multiply the 1 up, so we're having y minus 1 all over what? 2, 1 plus 2a, because y minus 1 times 1 gives y minus 1. So multiply by y plus 1 over 1 equals to 2 raised to the power a minus 1. Now if you look at these two expressions, y, both of them are the numerator at the top is the same, but the sign differentiate them. So since one has minus and the other one has plus and they are the same, that means difference of 2 squared. So I'll just take the negative 1 and square 2 value there. So we're having y squared minus 1 squared all over 2 raised to the power 1 plus 2a times 1 will give you 2 raised to the power 1 plus 2a. So this is what we have here, equals to 2 raised to the power a minus 1. Now, if I cross multiply, my y squared minus 1, because 1 squared is 1, is equals to the 2 raised to the power a minus 1 multiplied by 2 raised to the power 1 plus 2a. I cross multiply. I took the one down, the denominator here to the other side to multiply it. So, but we know that a raised to the power n times b raised to the power n is equal to a raised to the power n plus n. Indices, when the base are the same, just like what we have here, we're going to add the power. So we now have, if I implement this in the above expression, we now have y squared minus 1 is equals to 2 raised to the power a minus 1 plus 1 plus 2a. So I've added the power of these values up there. Now, in doing that, minus 1 here will cancel plus 1 here, remaining a and 2a. And a plus 2 will give us what? 3a. So I'll be having y squared minus 1 is equal to 2 to the power of what? 3a. Now we know 2 to the power of 3 is 8. So we have y squared minus 1 is equal to what? 8 raised to the power what? A. Now if I make y squared to the formula, my y squared is equal to what? 1 plus a to the power of a. So this is what we are told to prove. If you found this video helpful, please don't forget to click on the like button, and also don't forget to click on the subscribe button. Thanks for watching.